Hi guys, and welcome to this video. In today's video, we're gonna see the different privileged access levels supported by the Cortex-M microprocessor. We will see the major differences between the privileged and unprivileged access levels, as well as the association between the Cortex-M modes like handler mode and thread mode, and the privileged and unprivileged access levels. We're gonna see as well the different restrictions associated with the unprivileged access level, and we're gonna finalize this video by live session using an STM32 microcontroller and a Kyle Macrovision to demonstrate what we have learned across this video. The Cortex-M microprocessor does support two execution modes, handler mode and thread mode. After boot up, the Cortex-M will run on thread mode, privileged execution level. To switch to handler mode, we need to trap an exception or interrupt. Once we have trapped the exception and interrupt, the interrupt and exception service routine will run by default on handler mode. Handler mode will execute always in privileged execution level. To return back from our handler mode to thread mode, we need to return from our interrupt or exception service routine to the main application that will be running by default on thread mode. We can return either to thread mode running on privileged, or we can return as well to thread mode running on unprivileged. Hence, the thread mode can support both privileged execution levels, privileged one and unprivileged. To set our thread mode to run on privileged or unprivileged, we need to access this CPU special register, control register. And to be more precise, we need to access the Unpriv bit, which is the bit number 0 of our control register. If it is set to 1, then the CPU will run on thread mode unprivileged execution level. If it is cleared, then the CPU will run on thread mode privileged execution level. Privileged or unprivileged execution level, this control actually the access to the different CPU hardware resources and registers. While running on handler privilege or thread privileged execution level, the CPU will be able to access some set of special resources in terms of registers and hardware blocks. First of all, the Cortex-M microprocessor will be able to access the special registers like the control register, fault mask register, bus prior register, and pre-mask register. Also, the CPU will be able to access the different system control block registers. Finally, while running on handler mode privilege or thread mode privilege, the CPU will be able to access some internal Cortex-M hardware module registers like the SysTick timer registers as well as the memory protection unit registers. While running on thread and privilege execution level, the Cortex-M microprocessor will have limited accesses to certain hardware resources and registers. First of all, the Cortex-M microprocessor will not be able to access the control register, pre-mask register, fault mask register, and bus prior register while running on thread and privilege execution level. The Cortex-M will have limited accesses to certain system control and block registers. Memory protection unit registers as well as the SysTick timer registers will not be accessible while running on thread and privilege execution level. If the Cortex-M microprocessor is running on unprivileged execution level, and there are certain memory regions that has been defined by our MPU block and have associated only privileged accesses, then the CPU will not be able to access those memory regions that are protected against any unprivileged accesses. Any attempt to access those registers while running on unprivileged execution level will lead to user fault. Any attempt to access certain memory regions that are protected against unprivileged accesses by the MPU will lead to memory managed fault. So, this is our Kyle Macrovision project that will be loaded and executed within the STM32 microcontroller. As you can see, this code consists simply of accessing the system timer control register. We'll try first of all to access this register while having the Cortex-M microprocessor running on thread privileged execution level. Then we'll try to access the same register while having the Cortex-M microprocessor running on thread unprivileged execution level. And we will see that trying to access this register while having our CPU running on thread unprivileged execution level will lead to hard fault. Now let's try to load the binary into our microcontroller. So we are loading the binary into the flash memory. Then we will start a debug session. So if we try to explore the internal state of our CPU, we can see that the CPU is running on thread privileged execution level. Hence, if we try to access the system timer, and we can check even at assembly level here, that nothing will happen. So the R3 register will have the base address of this control register. And if we run, nothing will happen. Now let's redo the same experiment while running on thread unprivileged execution level. So we go back here, but this time we need to switch the CPU internal state from thread privileged to thread unprivileged. To do so, we go to our control register, bit number 0, which is matching this unpriv bit. If it is cleared, then the CPU is running on thread privileged. If it is set to 1, then the CPU will be running on thread unprivileged. Here we need to set it to 1, and here we go. Our CPU switches from thread privileged to thread unprivileged. Now, if we try to do the same experiment, and we access the system timer register, here store it in this R3 register, then we'll end up in a hard fault, as you can see.